Hi, Daniel. Hello. Hello, Daniel.
All right, good evening, everyone. We'll
Good
just wait
evening.
for a few minutes for others to join in, and we'll start.
Hi, Daniel. I've been trying to get to you.
Same here. Hello, can you guys hear me?
Yeah, I can.
Oh, good evening, Rahman.
Good evening.
Were you at the class last week?
Yeah,
I was not. Well, this is the third week of learning, right?
yeah.
Okay. I hope I did not miss much. Thank you.
All right. Good evening, everyone.
Good evening,
Good
Mr.
evening,
Daniel.
everyone. I'm hoping we can have a very interactive class today. I'm going to put off my video um, soon, but I just wanted to put it on so that I can explain. Please, as you can see, I'm actually still on the road. Um, it's a long story. I won't bore you with it, but I've packed and I'm trusting that we can do this in good time. All right. So how was our week? Hope we had a great week. Maybe we can get a few responses to the question, how was your week? What was it like? Did you go back to read up or practice or just research some more on some of the things you learned last week, if they were new or not? And yeah, anything else that you just want to share. So we can just take maybe a few responses and then we can. I don't think they can hear me. Hello, can anybody hear me? Okay, Osinachi, you're raising up your hand. Are you speaking?
Can you hear me?
Okay, yeah, please go ahead. Yeah.
Yeah, I mean, last week we were talking about Docker, right?
Yes.
But we focused too much on Docker. I feel like we didn't talk about it in a generic way as content. I mean, we are talking about containers, then we started talking about Docker, and we like doubled down
Okay.
on Docker. So, like, I didn't do much research. I just did a quick search
Okay.
on the whole container thing. So OCI, the Open Container Initiative, other runtimes like Podman, then what else? Just what a container fundamentally is, just an isolated Linux process with its own user space. I think I saw something about okay, I don't remember it, but something on steroids. So just user spaces, or is it just user spaces on Linux, isolated user spaces on Linux? So containers are basically just processes, just Linux processes. It's as basic as that. And yeah, so something like Podman.
Yeah.
If the Docker daemon dies, I think Docker uses container for its daemon. So if
Mm-hmm.
container dies, all Docker containers will die along with it. But for Podman, if the Podman daemon dies, other containers that were spawned by Podman would remain alive because they are like separate processes on their own. So
Mm.
those are just a few things I looked at.
Okay. Awesome. Awesome. Anybody else wants to go? Hello? No, we should have more response, please. All right, God's time. Thank you.
No,
Go ahead.
no, I was not around last week. What
Come
I
on, man.
wanted to say. I just joined back this week.
Okay. All right. Well, I guess you did well enough in the first week to be able to maintain your stance in the top 30 that you were
In
able
fact,
to.
I was surprised when I saw the news. I was when I saw it, I said, okay, let me take this thing seriously. So thank you very much for the opportunity.
Yeah, a
That's why I
chairman.
said it.
That's what it means. Yeah, a chairman. All right.
Thank-
Okay, so that's fine. Do you want to share something, or should we? Um,
no, no, no. I just want to listen to this class activities.
okay, awesome. Anybody else before we move on? Okay, so maybe we'll just do some quick housekeeping before we go into the meat of the day. Um, has anybody been able to use their vouchers to actually use it and subscribe and what's it now, and actually enroll for the course?
Yes.
Yeah, yes, yes. I've started my course today, so
Okay, awesome. All right. I just wanted to know if because somebody has reached out to me that they were unable to use their voucher, so that's what I wanted to find out. I think most, because I'm seeing some people say yes on the call on the chat as well. So I think so. Maybe I'll just have a separate conversation with that person, and we'll take it from there. All right. Can I also just do a quick check? How many of us already have Docker desktop installed on our computers? Just to just get a quick sense of the room. Docker desktop. Okay. Okay. All right. So please, what I want you to do, because two things. You've been given access to the course, but even if you don't have access to the course and you're on this call, um, there is you can go. Okay, the course has something called the labs, right? And so just a minute. The course has labs, right? And you there are different ways. The way he has done it, there are different ways to actually be able to access the labs, to be able to complete the different tasks and prompts in the labs there. The quickest way and the recommended way that he recommends is to use Docker Desktop. And Docker Desktop has this extensions aspect of it, right? So you go on Docker Desktop and okay, I think it's time. Let me just share the screen so we can just from there get into it. Sorry, just okay. Uh, it's not. It's called James. Okay. Okay. Sorry, I just want to share my screen now. All right. Can you see my screen? Uh, can you see my screen? Can you just confirm you can see my screen, please? Awesome. Okay. So whether you have access to the course or not, right? So you go to Spurin, his GitHub profile. Go to the dive into KCNA um, uh, repo, right? And then look for the branch So now this is for the labs, right? So you can either use Cloud Shell, use Docker Compose, or use the Docker desktop extension. All right. Now he recommends, right, that you use the extension, right? And when you go here, I'll put this link on the. I'll put this link on the chat. So he recommends that you use this instead. All right, if you have Docker desktop on your PC. Okay, so that's the first thing I want to. That's the first housekeeping thing I want to address. So that you can what it gives you is that it gives you an environment to practice some of the things that you're going to be doing in the course from here on out. If you don't have Docker desktop like me, I'm sure you'll be wondering why don't I have Docker desktop? It's because I use OpenSUSE Tumbleweed, right, as my OS. And sadly enough, as great as the OS is, there's no Docker desktop for my OS. I can't install Docker desktop on it. So even though I have Docker engine installed, but I don't have Docker desktop. So personally, I use the Docker Compose one. Okay. So if you are just like me, or for some reason or the other, you can't use the extension which he recommends, you can just be like me and use Docker Compose. You don't need to bother yourself about the Cloud Shell. Docker, these two options are fine. Okay, so that's what I will use. You know, moving forward. Okay, just a minute. Uh, start. Sorry. Kubernetes. It gives you a multi-node Kubernetes installation, right? That you can see how I just easily started it. And from what he's saying is that it's even easier with the Docker desktop solution. But for me, this works fine. And you have all the labs here. All right. So and you have access to this whether you have the course or not, whether you're registered on the course or not. So please, if you're here, just take note. All right. So and then there are all the different these things has all the different topics, right? Has their labs. So please use this. Yeah. And if you look at notes, let me see. Hope everything is. Oh, that's strange. That's very strange. Okay, we'll come back to why. Okay, sorry, I've not even gone through the labs to set it up. Uh, um, you're supposed to actually set it up from the first one. I've not even done that on this one yet. Anyway, so but that's not the main thing for that I'll be looking at. But I just wanted to explain all of that to you so that it's easy for you to go along. So somebody's asked me, can we use Podman as alternative? You should be able to. You should be able to, but I haven't explored that. So, but you should be able to. I believe so. But I haven't explored that, so I might have to like get back to you on that. Um, Hi Daniel. Sorry, what's the name of your OS again? Open SUSE Tumbleweed. Uh, Open SUSE Tumbleweed. That's what I use. Okay. So I just want to be sure so that before we go on. Okay. All right. Awesome. I think we can proceed. Now we will. If you look at the if you look at the topics that we're looking at today, that's container orchestration principles, Kubernetes architecture, Kubernetes cluster setup, working with pods, namespaces, deployment and replica sets, services and networking. Now, these things are uh, the best way that for me, right, the best way that I learn, right, is hardly through slides, right? And even when I'm speaking, if you remember the last time I even spoke, I used a mind map. So I hardly use slides for teaching or for talking or for doing anything. So what we are going to do is that we are going to use notes, okay, some useful notes. But then the major thing is to actually go into the documentation. Because by the time you start doing for the KCNA, maybe not too much, but by the time you start really doing Kubernetes, you'll be using the documentation a lot. All right, and so it's better you just now. All right, better you just start now and get into it. So the two parts we'll be looking at Kubernetes fundamentals and container orchestration just a little bit today. But most of you, I think it's only one person really that did not make it into the top 30. And I think everybody here is in the top 30, and you have access to the course. There are 25 people here. So by the time you, like we said earlier, by the time you go back, the idea is that when you hear something here that's not so clear, you go back to the course, watch the videos, play with the labs, and then you get to learn more. So use the course as a companion to whatever we're going to discuss here. All right, so we'll start with container orchestration, right? And now the first thing is really, okay, what Kubernetes, right? What really is this thing that we're all. So does anybody want to unmute to give us, maybe an idea that they already have of what Kubernetes is? Anybody? Oluwasegun, please go ahead.
Okay,
Just on,
thank you, Daniel. Good evening.
yeah.
Yeah,
Good evening.
so, from the explanation that Louis gave the first day, so he said Kubernetes is just group of containers. So that's what he said. He used the word group of containers that day. So that's what I understand about that.
Okay, noted. All right. Anybody else? Okay. All right. So anyway, so since okay. Enyelu J, you want to?
Yeah, I wanted to say something.
All right, go ahead, please.
That yeah. So I would like to draw. Good everybody. So I would like to draw a leaf from what we discussed the last class, right? Where we use where we create a Docker image for our application, and then after which we can then build the image, and then we can then run it as Docker containers, right? So now that we are also entering into Kubernetes, right? So by definition, right, Kubernetes is simply a container orchestration tool, right? What we use in container orchestration, and what does that simply mean? It simply means that we use it to coordinate, because orchestration simply means coordination, right? We use it to coordinate how we want our containers to to run on our infrastructures. Yeah, thank you.
Okay. All right. Cool. Thank you. All right. So let's just um, continue now. Kubernetes. Um, I won't give you any maybe those textbook definitions. I'll just give it.
I can't hear you. Is it just me?
I think it's from Daniel. It's from Daniel. So me
Yeah.
too, I can hear also.
Can you hear me? Hello. Hello.
Yes, I can hear you
We,
now.
lo- we lost
Okay.
you at some point.
All right. Sorry.
Just
Some
to,
people
yeah.
can't hear. Okay. So I was saying that in week one, right, we started with container. I'm sorry, cloud native. What is cloud native? What is just trying to understand the concept of it. Cloud architecture and cloud native architecture and those kinds of things. And one of the things that we saw was that containerization, right, is at the heart of cloud native. All right, because containerization gives us that ability to achieve a lot of the cloud native objectives. All right. Now, the next week we now went to going deeper into a container technology, and I think the most popular container technology really is Docker. All right, and we did that deliberately because we felt like having a deep understanding or a solid foundation in Docker or any containerization engine will really help. Okay, and now we're now going into Kubernetes. Okay, now the whole idea is that Kubernetes is this platform, right, that helps you manage, all right, multiple containers that do different things. All right. Now, that management is just a word for a lot of complexity. It's just one. All right. It's just one word that encapsulates a lot of complexity. That word manage, because it covers deployment, covers like scheduling, automation, auto scaling, so many things, all right, that is needed with several containers. Just think about it. You have so many containers doing different things, different applications. They need to be able to talk to each other. So they are talking about networking. They need to be able to people from outside, or APIs from outside or whatever, need to be able to reach your applications inside. All right, it needs to be able to scale. So you have a lot of you have a burst of users or a burst of requests. It needs to be able to scale to accept all of that, and then also shrink back when it needs to. It needs to be able to heal itself. All right, self-healing. It needs, it needs to be so that when a pod or a container goes down, all right, your application doesn't just die and you're waiting for you to come back to get it up. No, it needs to be able to come back up by itself. All right. So all of that complexity, all right, is what Kubernetes helps us to achieve. Okay, because if you remember, all these containers are just like small compute units essentially. All right, that you can deploy multiple on a single machine. Okay, but you need something. There has to be something that is controlling, like the puppet master, essentially, that is controlling all of these things. Okay, so I'm trying to give you, I'm trying to ensure that it's not we're not going with textbook definitions, but rather we are going with intuitive definitions. Now, to make all of that work, Kubernetes has different components. So I just realized I wasn't sharing my screen again. Sorry. Awesome. Can you see my? All right. Can you see my screen? Sorry, I didn't realize I wasn't sharing my screen anymore. All right. So Kubernetes has different components. Sorry, forgive me. Like I said, I'm not giving you slides. We're going into the documentation. All right. We're doing it the Kubernetes. Kubernetes the hard. What's that? Kubernetes the hardware or something.
Yeah, exactly.
Exactly. So we're doing Kubernetes the hardware. Kubernetes presentation the hardware. So now Kubernetes components, right? There are different components that make up a Kubernetes setup or a Kubernetes cluster. All right. Now, number one thing is that there is something you call the control plane. All right. You have the control plane, and then you now have nodes. All right. They're called worker nodes, different nodes. Now, these are machines. When I say machines, think of it as servers. All right, think of it as maybe virtual machines or physical servers or whatever, but these are machines, computers, servers. All right, that's what, when you think of node and think of the control plane. All right, now so those are the first separation. That's the first separation. So think about it, you need a master, right, that can run things in your cluster. You need like HQ, you need like a headquarters, you need somewhere where, for instance, if you look at the body, right, you have the brain. All right, so think of it as, okay, the brain, and then they cheese out instructions to the different parts of the body, all right, which are nodes. Okay, now with this work, okay, awesome. Under the control plane, we now have different components, all right, of a cluster. You have, the first thing is, where do I start from? Okay, let me start with the API, the API server. The API server is, it's kind of like the receptor, the guy that that is managing all the requests, essentially. All right, it's it exposes the Kubernetes API. All right, so it's because all the operations, the requests, everything goes through the Kubernetes API. All right, and it's that's Kube API server, right, is the central point. Okay, that all the API hits. Now, when a request comes to the API server, all right, you now have something else called the etcd. Or yeah. Now, what it does is that it's a value store. Think of it as a database. Okay, it stores all the configuration data. Do you understand? It stores all the configuration data. Like, so just think of it as memory for configuration. All right. So this pod, this thing needs to be scheduled, and all of that. It keeps a record of all the configuration, all the things that is happening within the cluster. Okay. And the next thing you now have is the kube scheduler. Now, the scheduler is what assigns pods, right, to nodes. Remember, I said nodes are, think of it as machines, as virtual machines or physical machines or whatever. All right. So the scheduler is what will now look like. Okay, where should this pod go to? Where should it go to? It assigns where the pod should be deployed into. And then you now have the controller manager. Now, controllers, all right, controllers are, how do I put this now? Controllers are what kind of operationalizes or extends Kubernetes API, the Kubernetes API. Do you understand this? I'm trying not to use the word plugin. You understand? I'm trying not to use the word plugin, but that's essentially what controllers are. So now you now have the controller manager, all right, that runs the controllers themselves, all right, because is with the controller manager that you can actually even use to extend the Kubernetes API. Do you understand? Because you deploy controllers to extend the Kubernetes API. So the controller manager is what manages all of those guys. So that's the control plane. All right, generally. Then on each node, right? On each node, you now have a component which is called the kubelet. Okay. Now, kubelet is like it's like for each node is like the local government chairman. let me put it that way. Think of a node as a local government, and then the kubelet is like local government. It's like the captain of that small ship. It's like the captain of that small thing, and it's the one that ensures that the pods are running. It ensures that the containers are running. It's the one that gets the pods. I think I've not even explained, this thing of pods, these terminologies of pods and containers, because we've been talking about containers since, and now we're talking pods. But I'll come back to that, Sha. Now, because if you remember from last week, right? Containers are instances of images, right? If you remember. So the kubelet is the one that pulls down the image, all right, and runs the containers in the pods. Do you understand? So that kubelet is the one that just ensures that for this node where he's in control of, right, the containers here are running, the pods are running, all right. So that's his job essentially. Then you now have the kube proxy, which maintains network rules on nodes, all right. So when it comes to like networking between pods talking to each other and all of that, the kube proxy is very, very active on that. So you have this on different nodes. Okay, so each node will have a kubelet and can also have its kube proxy. So for each node, all right. The kubelet also is actually also runs on the plane as well. Just that most people don't talk about it. Okay, that it also runs on the control plane, but it actually does as well. Because these things run on the control plane as well. Containers run there as well. Pods run there as well. So the kubelet has to be there. And then so container runtime. Those are some of the other things there. Now, so when you're looking at the core components of Kubernetes, these are the major things. All right. So you're going to these are all the things that you just be dealing with when you're working with Kubernetes, essentially. Any questions so far before we proceed? Just to be sure, let me check the charts. When you like EC2 instances, when you say when I was talking, was it that when I was talking about nodes? Yeah, if that's what you mean, yes. So somebody says he has a question. Go ahead, please.
Yes, can you go back to the documentation? Because I was seeing that cloud diagram. What does it do?
You're saying what?
This cloud provider API. Oh, okay. You mentioned it already.
Yeah. So the thing is, Kubernetes. I mean, I'm sure you must have heard of EKS. You must have heard of AKS. You must have heard of GKE. These are all um, managed Kubernetes in the cloud. All right, and um, they also interact with the Kubernetes API. They have to, okay, because from the Kubernetes, for instance, if you're provisioning a load balancer, all right, it needs to talk to the Kubernetes cluster, and the Kubernetes cluster has to talk to the cloud API, cloud provider API. There are different services like that. All right, that's because somehow it has to be accessible. So it's just easy to run it on the cloud, even though of course you can do it on prem, you can do it and still set up and all of that. But that's story for another day.
Okay,
All
thank you.
right. Yeah. Any other questions?
I have a question too.
Please go ahead. Yeah.
Yeah, so um, the kubelets are like agents that are installed on the worker nodes, right?
Yes. But they're also
So
they're also on the it's also on the control plane as well.
it's on the control plane. So the control plane is the master node,
Yes.
and the worker nodes are the ones that
They
do
work.
the actual container provisioning.
Mm.
So when Kubernetes is installed, or when the Kubernetes ADM is installed on the master node computer, how does it then get the kubelet to be installed on each worker node?
Okay. So when you are um okay, now we're still going to get to uh, uh, actually installing. Wait, would we get to that in this, because there are two, it's broken down into 2 days. Okay. Now when you are installing part of the installation, if you look at the documentation here, just a minute. Um, installing. There we go. Now, part of the installation process when you are using kubeadm, all right, what you do is that you first of all set up your control plane. You install kubeadm, all right, and then you now add you now go to a worker node. You install. Wait, hold on. You now add the worker node to the control plane, okay, and then it's so part of the installation, part of the what's it called now, part of the, yeah, there we go, installing kubeadm, kubelet, and kubectl. Yeah, yeah. So part of when you are adding a new worker node to your cluster, all right, part of that installation is that kubelet will also be installed as well, especially when you're using kubeadm. All right. However, you can still do it manually, the hard, all right, by installing all these components one by one on the different worker nodes. Do you understand? So, for instance, you can see this command here. It installs the kubelets, kubeadm, kubectl at once.
But this is for the master node.
Both of them.
Wait, on each worker
Or
node would also have all the components.
not all the components. Kubelet. You asked about kubelet.
Yeah, I asked about kubelets. I'm asking if okay, so
No, it won't have. Not.
on each worker node you
It
can.
won't have. Yeah, on each worker node, you install kubelet, kubectl, and kubeadm.
Okay. So
Yeah.
does Kubernetes have this thing where it promotes worker nodes to master nodes, or is that beyond it?
what?
You know, there are some distributed systems where if the master node dies, the worker nodes can take up.
Yeah. So well, the thing is, it depends. It depends on on how on the setup. All right. Now it depends on. So, for instance, if in a distributed system like etcd, you're probably looking at something like that where they do elections, and if the master is down, you get another leader. All right. It just depends on how you set up your cluster, really.
All right, thank you.
Can I add to that?
Yeah, go ahead, please.
Okay, yes. I think it's also Nachi that asked the question. So the kubelet, you install the kubelet, like Daniel said, on all of the machines. Kubelet is responsible for, and to answer Mohammed's question as well, the kubelet is responsible for ensuring that you have your pods running on the nodes, and you could have pods running on the control plane as well. And then speaking about promoting a worker node to making a worker node a master node, I believe you're referring to control plane. But there are different things. So the control plane is not a worker node, and the worker node is not the control plane, primarily because of the components that are installed on them. So on the control plane, you have things like the Cube controller, the Cube API server, Cube scheduler. Those components make up what you call the control plane. So whatever server that you have that installed upon, that becomes the control plane, or what you're calling master in this case. So you cannot promote a worker node to becoming a master node, except you want to have all of those components installed on them as well. I hope that's clear enough.
Yeah, that's clear. Thank you.
Cheers.
All right, and yellow.
Yeah, good day. So from your explanation, right, you said that the kubelet is responsible for managing the pods and ensuring that the pod are running the containers, right? And then you also made mention of the kubelet, the kubelet also being found in the control plane. So what is the function of the kubelet in the control plane?
Because just like Larry just mentioned it, that even on the you can also deploy, you can also um, run
You are
pods.
breaking. I couldn't hear you. Is it just me?
Yeah, Daniel, you're
You
breaking.
know, and containers on
You are
the
breaking.
control node as the control.
I didn't hear you. Hear you. You are breaking.
Okay, while Daniel is trying to get
Hello.
his audio. Yes, Daniel, we can hear you now. You were breaking up a bit.
Okay. It should be. I believe it should be better now.
Yes. Yes.
Hello.
Yes, we can
Yes,
hear
I
you
can
now.
hear you.
Okay. Okay. Awesome. All right. What was I saying? So can you remind me what the question was? I think I lost my train of thought.
Yes. My question is was that the kubelet, right, functions as like the kubelet in the node, right, helps the pods to function properly, right, by ensuring that the containers are running, right. And then you made mention that the kubelet is also present in the control plane, right? So, what is the function of the kubelet in the control plane?
Okay. Yeah. So like I was saying that pods, you can also deploy pods on the control plane. Do you understand? Like you can also actually run workloads on the control plane. So containers are running there. Do you understand? So so the kubelet is also.
No, you are breaking again.
I can assist with that question as well.
Okay,
Is
please.
also working there. If you heard me.
No, I didn't
Daniel,
hear
you were
you.
breaking, but I can assist with that question. So you can have, yes, good, and it's a very good question actually. So many people don't know, but you can have workloads run on your control plane as well. As a matter of fact, you can have your application run on control plane. However, if you use, it's not advisable actually to have workloads run on the control plane because of separation of concerns, and so that you don't break things. So when you create a cluster using kubeadm, what kubeadm does is that it drops a what you call a taint on your control plane, so that workloads are not being scheduled upon that control plane, so that you don't run apps on them. That's what kubeadm does. It drops a taint to say, oh, no schedule, don't schedule any workload on this. However, as well, when you use kubeadm to create a cluster, it installs those components, the cube scheduler, the cube, which I believe will be spoken about later on, the cube scheduler,
Adebi, I can't hear you.
the API server. It installs them on the control plane.
Yes.
Hello.
Was I breaking as well?
Yes, you are breaking at some point anyway. Yeah.
But did you get my message? So the kubelet,
Yes, I got
um,
when you said that the cube ADM
yes,
drops a tint on the control panel, right? Which
control plane.
instruct it not
Control
to
plane.
on the control plane, which instruct it not to run any job, right? Or yeah, on the control plane.
On the control plane, yes. However, I mentioned as well that kubeadm, when you use kubeadm or some other tools to create a cluster, what they do is that what the components that make up Kubernetes, e.g., scheduler, API server, etcd, all of those services run as containers on your control plane. So, and what is responsible for making them run as containers is the kubelet. That's why you need kubelet on the control plane. Does that make sense?
Mm,
But it's a
yes,
great
it makes
question.
sense. Yeah, thank you.
Cheers.
Yeah.
All right. Can you hear me again? Can you hear me now? I've changed the
Yes,
internet.
I can hear you. I can hear you now.
Okay. Awesome. All right. So we can continue. So let's go back to outline. Uh, okay. If there are any questions, you can still bring them up whilst we're going through the outline. Okay. So we've talked a bit about. Let's see, where are we now? Just Kubernetes fundamentals. All right. So now let's go. Let's look at pods. So now, what are pods? Anybody wants to start? Uh, already. Okay. All right. So we have talked about containers since. We've been talking about containers since. But pods, in Kubernetes are actually the smallest unit. Okay. So of computing units. So containers run inside pods. Do you understand? Containers, run inside, a pod. Now you can have multiple inside a pod. All right, that's very possible. However, even though best practice is that you run one container in a pod. All right, but there are times when there are different instances where you run multiple containers, especially there are some things called init containers. There are different kinds of, so there are different reasons why sometimes you might run multiple containers in a pod. Okay, but most times it's just better to run a container inside. Now, how do we go about use it? Now there are different ways. Okay, or rather they're majorly, they're primarily two. They're majorly how do I put this? You know what? Let's just go straight to the. Sorry, we're really doing Kubernetes the hard way. Or what's the but this will be tough. Okay. Okay. Let me see. I shouldn't have anything. Okay. All right. So let's quickly run. So a pod is where, so let's, the quick way, so we'll just quickly run an Nginx pod. So, and then we'll quickly look at it to see what. Let's run this. Okay, so what we've done now is that, okay, we're running a pod, and then we're running an Nginx image. All right, that's why we did this. We're running an Nginx image in the container. All right. All right. So what I wanted to do is to just for us to look at, okay, now inside that pod, all right, there is a container running. So it says container, so that tells you that, okay, there's a possibility to have multiple containers in it. So now what's the name of the container? Is an Nginx container. What's the image? Just like we had already seen from last week. This is the image it's getting it from. And then, of course, even much more details on how it was pulled, so you can see the logs, the events that happened. Okay, so it says default scheduler. So remember we talked about the scheduler. All right, it scheduled it and said, and then also got the pull down the image. Okay, even though I already had this image on my machine, so that's why it says present on machine. But if not, it would have pulled it and then created the container, and they started the container running inside this particular pod. Okay. Sorry, just a minute. So that's one way. What we did there was to just run it imperatively straight from the command line, just like that. Well, another way really is to, okay, maybe you use a YAML file, and then you define the API version. You define, well, these things are, if you look at, so what's the API version for the pod object? Okay, what version is it for in the Kubernetes API? So it comes in version 1 of the Kubernetes API. So what kind of object are we trying to create? A pod. Okay, and then so what containers do we want to run? Nginx, what's the image, what port are we exposing, and then this is also how we use kubectl and then we apply the YAML file in the in the in the Kubernetes cluster. So that's pod. It's the smallest, is the low, is at the is, let's look, if you look at if you think of it as a hierarchy. All right, so you have the pod, then above the pod you now have maybe a replica set. But before you even look at replica set, you have to look at deployment. Okay, now remember we're looking at, okay, what's the looking at the formality and the reasons why we're even using Kubernetes at all. Deployment is at the heart of it, because with a deployment, all right, you are able to sorry, just a minute, with a deployment, actually you are able to you know scale. You're able to scale, so that's where you really get the power to be able to, like, scale the pods, define how many pods you want to run, and then it also provisions something called a replica set. Now the replica set is what, say, so for instance, if you say you want 3 pods of this particular container to run, okay, the replica set is what says, is a controller, right? So it's that replica set that says, okay, you know what, we must have 3 pods. So even if you kill 1 pod, okay, it will bring back, it will recreate or create another pod, to ensure that definition is met. All right. Sorry, I think I flew better with questions. Are there questions so far? Just to check.
Yes, I have a question.
All right, go ahead, please.
I still have not been able to connect. Like, what's the connection between deployment and pod? I don't get what you said there.
Okay. So in the air, what the compute that is actually running is, so first of all, you want an application to run, Abi? That's the goal. That application, you now packaged it inside a container, right? We know that much from last week. Okay. Now in Kubernetes, that container, right, is now inside a pod. So in Kubernetes, it doesn't deal directly essentially with the container. It deals with a pod. It's called, there are different objects in Kubernetes, and the smallest object is a pod. That's where containers run inside. Okay. Now Kubernetes now is able to now orchestrate and use those pods and deploy it however it wants. So you can now, there's now an object in Kubernetes that is called a deployment. Okay. And this deployment, you define it to say, okay, you want, okay, so let's look at one deployment here. So you say, okay, you want 3 replicas. So I want 3 replicas of this container. Okay, let's say it's you've built an app. Okay, all right, let me use that. So you built an app that you want 3 replicas of. Now why would you want that? So that when there is maybe a lot of requests or a lot of traffic on one, all right, or on the site, you can distribute that traffic amongst these different instances of your application. Does that make sense?
Yes, it does.
It makes sense that, okay, if I don't know if you know that, okay, you can actually have maybe let's use EC2 now, right? You can actually have different instances running the same website or the same web application, all right, and then you now put a load balancer in front of it. I don't know if you know that much about being able to
No,
manage
not
traffic
really,
like
but I understand the explanation.
Okay. So now think of replicas like that. So you want to say, okay, so I want 3 instances of this my application so that I can have traffic distributed between this number of replicas. Okay. Then you are able to now. How does Kubernetes now? Later on, we're going to look at some other things like selectors and things like that. So now Kubernetes now has a way to say, okay, this. Hello. Okay.
Yeah,
So
yeah, we can hear you.
okay, yeah. So Kubernetes now has so the deployment is the way that Kubernetes manages that whole process of, okay, how many deployments, how many replicas are we going to have? Okay, that's number one. But that's not all. Is the deployment that is a, we talked about controllers earlier. So the deployment is actually a controller. Deployment that now says, okay, you are able to scale this thing, the way you want. Okay, you can increase this replica here and say, okay, you now want maybe 4 or 5. Okay, so it increases the replicas of that website. You can now say, okay, we have an update, all right, and we're updating our app. So you put it out there, and then you now see that, oh, okay, maybe we made a mistake or something. We want to do a rollback. We want to take it back to the version that it was yesterday. The deployment is also able to help you do that rollback. Okay. What else am I missing for deployment? So those are I think the major things regarding deployments. Those are the major things, but then in the documentation is quite a bit more detailed. So that's that. Do you have a follow-up question for that, or is it clear?
Yeah, it's very clear. One more question. Though I will go over it again. Concerning the
Mm.
replica that you mentioned now, those replica are from the original application. Does it mean that if you destroy the original application, does it affect the replica? Or the replica just takes everything the original application has?
When you say
I
original
don't
application, what do you mean?
you said like you said when you deploy an application and what the replica does is like to create multiples of that application. What I mean by destroy is that maybe the application does not exist anymore.
No, so remember, that's why we need to connect from what we learned last week in terms of how we build containers. You're building an image. Remember, we talked about image is kind of like a blueprint. Do you understand? Like, it's a model to say, okay, this is how, and then all the containers that are running are just instances, are just like instances of those images. Do you understand? So you're not, there's no original thing per se that you are going to destroy. Do you understand? Because the containers are being gotten from the images that you've already pushed out there.
I get now. Thank you.
All right. Okay. Any other, in terms of costing, does the number of replicas you have impact the cost? Okay, so when you're looking at cost, um there are different things that come to play, but the major things is, okay, how many nodes are you running? All right, because if I'm just taking this from the angle of you're running it in a cloud and you're using instances and all of that, where, so you're looking at how many nodes are you running, because that matches the if you're running on AWS, the EC2 instances that you are, so that will affect your cost there. If you are running a load balancer, right, that you are provisioning from the cloud provider, that you're using from the cloud provider, that will also affect, that will also impact your cost. All right, and the type of instances that you are running. But however, those are costs. Those are hard costs. But when it now comes to inside the cluster, you're not paying per replica or per, you get, it doesn't really impact. You can, if your node, if you are paying, let's say you are paying $20 per month for a worker node. If that worker node is able to accept maybe 50 replicas, just for instance, maybe it's powerful enough and is able to handle that amount of workload, right? So that's it. Even if you are whether you are running 3 or you are running 50 in worker node, is the same cost. You get it doesn't impact in
Okay,
that regard.
since the node is the virtual machine which you're actually paying for, whether you run 20 pods, it is actually immaterial because the number of pod you run actually then shares the available resources of that virtual machine that you have, right? And
Yes,
it will determine if it will be faster or slower,
yes,
as the case may be. Okay, okay. I think I get
yeah.
that.
Joy, you're raising up your hand. Hello. Okay. All right. So
I have a question. So I'm trying to. Can you hear me?
go ahead, please.
So I'm trying to understand these deployments. Like, how do from your explanation, I'm not trying to understand how they help in managing applications. Is it that what the daily tasks they do is just creation of replica sets or what? I don't really get or replicas. I'm still trying to
Okay.
understand
So
how
all right. So let's go back to what
explanation.
let's go back to the goal. What we are trying to achieve with Kubernetes. Well, we want a system that um, our when we can deploy we can use want a system that we can use to deploy several multiple containers, right? That's one. We
Yeah,
want
yeah.
a system to one multiple containers, right? We want to be able to roll back. Roll back means that okay, if we want yesterday's version or we want a previous version, we can just easily go back uh, to that state. All right, that's one.
Yeah.
We want to be able to in scale. We want to be able to scale up. So if, for instance, we are running 3 replicas, all right, and we want to go to 10 replicas at once, all right, we want a system that can easily manage that for us, right? We also want that okay, if we want
Okay.
to scale down again, we can also just easily scale down. All right, that is so. That's what the deployment helps us to do. You can update your what's it called now? You can update your images. Set new images. Update your applications. Very easily. Yeah, and just manage the amount of replicas that you have deployed. Do you understand?
Okay.
Yeah. Now, again, one more thing. Let me also talk about this. So let's take this use case. Okay. Um, you have an application that is running, but you want to and there's an update to that application. All right. How do you update it and ensure that there is no downtime? So let's think about it outside of Kubernetes now. How do you do that? That there is no downtime. So you need to update your application that is running online. Maybe you are running it. Let's even say you're even running it using Docker self, and you need to update it without any downtime at all. That's one of the things. Sorry, sorry about that, please. Like I said, I'm in the car, so all right. Do you understand? So that's what deployment. That's what deployment helps us to achieve. Those are some of the things that deployment as an object inside Kubernetes helps us to achieve. All right. Hello. Hello. Okay. Is that clear? All right, so let's
So for sorry, for updating now, are you saying they're going to have to write the script? Will this stop the running container? Like I don't understand how you explained for this updating. So you
so
said if you want to
it will,
update,
the way it will go about the way the deployment will go about the updating. So depending on the strategy that you also define, but the default strategy is called rolling update. So what that means is that, so let's say you have three containers running of your application. Instead of it
okay,
to bring down, you know what it has to do is that it has to replace the containers, right? So normally,
yes,
instead of it to bring down the old application and then now start up the new application, you know, if you do that, uh there'll be a period of downtime.
the downtime,
Abby, you
yes,
uh
yeah,
so but
yes,
rolling updates, right, is that it will bring down one, okay, of the old version and take up a new a and spin up the new one. All right, bring up a new one of the old one, bring down another one, bring up another version. Do you understand? Bring down one, bring out another version. Okay, so you can set it up in such a way that,
oh,
okay, you know, you can, you know, I mean, one of the good things about Kubernetes is that you can practically configure, you know, practically almost everything. So you can set it up in such a way that you can say um, only 50%, all right, should be down at any time. All right. So let's say you have four replicas running, the max that can go down at any time is two. Okay. So two of the old version of the app will go down, and then it will spin up two and ensure that it is properly running, okay, in a healthy state, before it will now attempt to bring down the remaining two containers of the
okay,
old ones, and then bring up the two new ones that are left. Is that clear in that aspect, in that regard?
yes, yes, it is. Thank you.
Okay, Emmanuel Christopher, I think.
Okay, my question is, what is the default strategy that Kubernetes uses for this deployment? Because to
That's
an
what I said.
extent, in my reading, I noticed there is Canary, there is blueprint deployment, there is rollout, there is A/B testing. But what is the default? Or can you set Kubernetes to function as either one of these, or does it have a default deployment strategy?
Yeah, the default is rolling update. That's what I was. The default is rolling update. That's the default.
Okay, okay,
Yeah.
okay. Thank you.
All right. Um, let's see. Let's go to the. This one. Okay. We looked at. Okay, so let's look at services. Okay, I think let's look at replica sets before looking at services. Sorry. Um, now the hierarchy is this: deployments, control replica sets. Replica sets, you know, control, you know, the pods, or above the pods. Okay. Now, what is replica set? Is to The idea is that if in the deployment you say how many replicas do you want, you say three. The sole job of the replica set is to ensure that at any given time, right, three pods are running of that application. Do you understand? So it's that replica set that will always ensure that, okay, if by some reason, one way or the other, one pod dies, or maybe you go in and you delete a pod, right? You know, the replica set is that controller that says, you know what, well, you know, the idea is that it matches, it looks at what the current state of the cluster, all right, and looks at what you have defined. There's this whole idea of declarative configuration, and that's what Kubernetes works with. So you declare that, okay, this is the desired state that I want this cluster to be in, all right, through the deployment. And then the replica set keeps looking at the current state of the cluster to say, okay, how many of these pods are running currently? It keeps looking at it, it keeps watching it. If for some reason that number doesn't match, it will ensure that it goes back, the current state goes back to what you have defined. All right. So that's for replica set. So let me just quickly run. That's what I just realized. Let me just quickly. So let's run this. Let's quickly run this thing here. Let me see. What did I do? Well, is that part clear? Whilst I'm working on this, trying to get a deployment up. Let me just handle here. No. Okay. Let me jump to services. Sorry, I'm jumping around. All right, let me just quickly explain services before we move on. Now, so you have a pod running, right? Or you have, your deployment and your workload is running. But how do you expose? Now, okay, let me start this way. If you remember last week when we looked at running containers and using your Docker file, one of the things from the Docker file is that you can expose a port. Do you remember that aspect? You expose a port. So let's say your application is expecting to be reached on maybe port 80, right? Let's just use port 80. So you expose the container on port 80. All right, but now you've put the container inside a pod. All right, so you need to expose that pod. Do you understand? So that requests can get into, excuse me, so that requests can get into the pod and into the container, and of course into your application. All right, so service is an object, right? It is an object that is inside, is one of the Kubernetes object that you use, all right, to expose pods. And then there are different kinds of services, but because think about it, pods need to talk to each other. So that's one level. Now these workloads are running on nodes. Okay, so that node, all right, is also an object in Kubernetes. You can also expose that node, all right, so that that node is reachable. Okay, now by default, when you set up your cluster, nothing from outside the cluster can reach into the cluster. All right, so you can set up like a load balancer service, type of service, okay, so that from outside, the pod can from outside, traffic requests, connections can enter into the excuse me, into the cluster. All right, so and then you attach you so essentially what you are doing is that you are exposing, your pods you are exposing your pods on a particular port, all right, to be reached. Do you understand? And of course you can also define what kind, not just what kind of um or the level of exposure that it will have, but also what pods are, what other services are open to it. Sorry. So sorry. I didn't want to give excuse for not for not being able to attend this meeting, even though I'm on the road. Sorry. Okay. So is that understood though? Is that clear? This area of service
Not
is it
not very clear.
okay?
Not
So
very clear.
so far what we've talked about is objects inside the cluster running, all right, workloads running, but we need those workloads to be able to communicate either with each other, all right. So for instance, let's say you have a pod that is running your application, and then you now have um another pod, maybe. So let's say it's a microservices architecture that you are running, all right. So you have a pod that is running maybe your authentication. Let's use the common examples. E-commerce application. So you have the other microservice, all right, that is running in one pod. You now have the checkout or maybe cart service running in another pod. Now these pods they need to communicate with each other, right? Do you agree with that? All
Yes,
right.
yes, sure.
Okay, so they need to communicate with each other. Now, one of the things we learned, all right, starting from last week, is that uh containers, all right, are isolated. All right. The way they are, they leave the application inside of them, live as if that's the entire computer, that's everything. Okay. So there is no communication with the outside world just on its own. Now the service, what it does is that it now opens up a portal, or it allows that, okay, this pod can talk to, or can be spoken to, or can be reached, in so and so, by so and so port. Do you understand?
Okay, like when we are creating the Docker file, for instance, right? We kind of specify the ports we want the application to be reached on, right? The
Exactly.
container to be reached on, right? So let's say the port is port 80, for
Yeah.
instance, right? And then you come into this place and you create a kind which is equals to service. Let's say the application name is e-commerce, right? So you put the name as e-commerce under the metadata, right? And then what does this port now do? Does this port tell it that, okay, that this service I am speaking to, it is in port 80 or something? Like, what does that port section actually do?
Now, um, you have the container, right?
Mhm.
That you have already now encapsulated. That you have already now, think of it as you've wrapped it up inside a pod.
A pod, yes.
You understand? Okay.
Mhm.
Now that container has been wrapped up. So even though you opened up a port in the container, all right, it's not yet accessible because the um think of it that, okay, you put something in a bottle. If you don't open that bottle, right, nothing,
Mm.
no matter what you put inside, nothing can access it. Do you understand? So I want you to
True.
have that image. So if you put inside it, if the container is running in the pod, okay, it's not accessible. But when you now attach a service to it, all right, you now open a port. So you now say, okay, um, so let's look at this. You can see this YAML file here, right?
Mhm.
This thing here. So it says what protocol you are defining. So now you're not defining the port that you want to open. Okay. So it's now saying, so what protocol? TCP. Port. What ports do you want to open on the pod? All right. So you open port 80. Now, what ports do you want to target inside the container?
Okay.
Do you understand? So you open. So it's mapping. Is very similar to what you've done from in your, what is it called, in your, with your container. Okay, but you're just opening it up again at another level. For the pod. Is that
Yeah, so this target port, because I'm seeing that, okay, that this port is telling you that, okay, when you open the pod, right, expose it on port 80, right, and then the target port is telling it that, okay, this is the port you are targeting, that's 9376,
mm,
like this is the port number of the pod or something. This target port, is it the port number of the pod?
no, this is, so you're opening port 80 and you're saying it's targeting port 93 something, as in the target port, inside the container. That's, so I don't know, how do I explain this now? um so you defined a port on the container, right?
Mhm.
So
Yes.
now, and it is running inside the pod. You open port 80 um on the pod, all right, and you're targeting it to the container on a certain target port. Wait, no, sorry, I've mixed that up. Sorry, I've mixed that up.
Okay.
Sorry, I mixed that up. Sorry, that's wrong. This target, sorry, the target port. Um, I'm gonna have to get back to you on this. I think I've mixed this up.
All right. All right. No
Yeah,
issues.
yeah. All right.
That.
All right, Larry, you want to say something here? Hello.
Hello, can I easily explain? If can you hear me?
Yes, I can hear you.
Okay. If I can easily explain that port and target port to who asked the question.
Yeah, go ahead.
Okay. Yeah. So imagine you've built your image, and let's just say like a simple Flask application, and on this application it runs on port 30,000. So
Yeah.
you've built it into an image, and you're now running it. So now this pod, or what the service is doing. So that port number is the port you're reaching on that service. And then that target port, let's just say like you've defined that application now. So if you're defining that YAML file, you put your target port as 3000. So if I were to put 80 on that target port and it will hit 80 on my image and it won't get anything. But if I put 3000, which is the Flask app you've built on that image and what is running on, it will hit the 30,000 on your image. So basically, that target port is the port your application is actually running on. So that service is, you could define anything in that service. It doesn't matter, but that's just what this the port you're reaching on that service. So if you were to maybe um at least from my understanding, is that there?
All right.
Okay. So the target port is the port number uh,
Application?
of your container that is running. Yeah, of your
Yes.
application that is running. So,
Yes.
but there was something that Daniel said earlier, right? That the application is running, but it's like encapsulated in the pod, right? It's like
Yeah.
it's closed in the pod. So if it is closed in the pod, how does it have access through the pod and then
Okay.
communicate with the container?
So pods, like like a pod being the smallest unit, we could have multiple containers in a pod.
Hmm.
So services works on selectors. So if you were to put a label on the pod, maybe app equals to flask. So that's how your service is, like your service cannot work without selectors. So whatever label you put on your pod, that's how the service will know which pod is hitting. So you could have like 20,000 different multiple applications, and if they have that same label, that service will be hitting all those pods. So on a pod, you specify the label, then the service reaches that pod based on the label you specify. Then on the target port, it then tries to reach the application on that target port defined on that pod.
Okay, on this selector part of it, right? Shown on the screen, I could see something like app.kubernetes.io/name. Uh, then we have proxy.
Yeah, so that's the label the person probably defined on his pod. So now if you look
Okay.
up now, you'll see the labels there. App. So this is the pod. So this is how the selector knows the pod. So that's how the label that is there. So this service now will
Oh,
reach any pod that has this label, no matter what. It could be an Nginx, it could be a Flask, it could be anything. As long as it has that label, that service will try to reach that pod.
okay, nice, makes sense. And then it exposes it on port 80. All
The
right.
pod, the pod. Okay, yeah, yeah, yeah.
It exposes it on port 80 as specified down, right? Yeah.
Yes.
No, the pod itself is exposing port 80. So that port you're seeing is not what the it's not, how would I put it?
Okay.
All right. So let me. So thank you, Dwayne Chima. All right. Thank you very much for stepping in there. Um, so now when you are defining, I think I jumped to this part when we're talking about pods and deployments. When you're defining objects or some objects, there are these things called metadata. All right.
Yeah.
So the metadata is just uh, like you're tagging something with more information. All right, you're annotating something with more information about that thing. Do you understand?
Mm-hmm.
So now Kubernetes has this thing called this metadata of labels, and the way
Yeah.
and that's a very very key aspect of how Kubernetes works. So you give something a label to say. So in this case now they've given it this label to say um, you know it's key
Yeah.
value, right? So the
Y-
key is Kubernetes, this long thing here, app the
Yeah.
kubernetes.io/name. All right. Um, so that's the key. And then the value for the label,
It's
all right. So
proxy.
it's called proxy. Do you understand? So now,
Okay.
and then they went ahead to define the pod, and all of that. Now, to attach a service, because a service is an object on its own, to attach a service to this, all right. Um,
Yeah.
the way to go about it is to now in the spec, now notice where this is being defined. In this
Yes.
under the spec, all right, you now have a selector. Like,
Okay.
where do you want what's what do
Do
you
you
want to
want to
attach?
use
What do you want to attach this service to? Okay, and then
exactly?
it's now selecting that label. So no matter why this is important is because this thing is ephemeral. It comes at it. A pod can die. A new one can be spun up. You get, like, there's no, it's how do I put it, it's not long lasting. Do you understand? Like,
Yeah.
they come up and go, so you can't say, okay, this particular pod, I'm attaching this service to it. All right, so what they've come up with, which is really brilliant, is that there are these, so any pod at all, right, that has this particular label, all right, that has this particular
Yeah.
label, this value, um will be will be attached to this service. You
Yeah.
understand?
Yeah. So
So
in my
now,
head, the label is
yeah,
a unique identifier that I can use to track a particular pod. Right. I think I get that.
yeah.
I think I get it. Thanks. Thanks a lot, Daniel. Thanks, Chima. Yeah.
Okay. Okay. So, any other questions regarding service? There are some other parts of services that we've not gone into because it's quite because service as you're reaching service, you're now beginning to reach the networking aspect of Kubernetes. All right. So it's quite broad. Like I said earlier, there are different types of services. Um, the one that we even looked at earlier. So the default type of service in a Kubernetes cluster, right, is cluster IP, which essentially allows you know inter cluster communication, right? So to pod communication. Do you understand? So, but it doesn't allow anything from external. All right. But then there's let me see, where's this one? Yeah, the node port. All right, node port allows you to attach a service to a node. Okay, so it opens up the node to access the understand through that service. There's another one, the load balancer. The load balancer allows like external traffic. All right, but however, the load balancer also works with like cloud providers API. All right, so for instance, if you are on what is it called now, if you are on AWS, okay, and you provision a load balancer service, okay, ideally it will provision like a load balancer in your Kubernetes, sorry, in your AWS account, and attach it to that, so that will work. But again, like I said, sorry, question. Does service assign a port to a pod? Does service assign a port to a pod? What does that mean? Does Please, Joy, if you still have this question, you can
I
unmute
was a
to.
bit I was a I was a bit confused. So I read about how services and the difference between the ports and the target ports. But I've read it and
Okay,
I've understood it. Yeah.
all right. Hi, do I configure a service with Nginx run in specific virtual server? Edwin, I'm not sure what you mean by this. Okay. Anyway, so do we have any other questions before we move on? Okay. Anyway, so what I've done essentially is to just brush through the topics. Oh, we didn't even talk of namespaces. All right, namespaces. Let me just quickly talk about namespaces. Um, let's see. Architecture. Namespaces. So I'm trying not to search, but okay. Namespace. So, but the idea for namespaces, right, is that you can have one cluster, but have it sectioned. Do you understand? Like you can section it to depending on how you want. Do you understand? Like you can section it to say um, this. Okay, let me just read out what is here. Kubernetes namespaces provide a mechanism for isolating groups of resources within a single cluster. Names of resources need to be blah blah blah. Okay, anyway, So you can say, let's say you are in a company where you have multiple applications, and you also have like multiple teams. Sorry, I hope can you hear some from the background? Sorry about that. Multiple applications, multiple teams. Do you understand? You can section you can isolate the different applications and the resources needed to run them. All right, so the deployments, all the services and everything, you can section them into like logical groups, okay, like groups of resources, okay. And when they are inside that name group, okay, it's as if they're different, they're like, there's like different clusters almost. All right, so there's no connection between one namespace with the other, even though you can do that connection generally. But then there are also some other objects as well that are cluster wide. So persistent volumes. So for instance, persistent volumes, we've not talked about that. Nodes, of course, nodes, which are the machines, are also cluster wide. So it's not one namespace, that is not a namespaced, so that's just like, it's just a way to group different resources inside your cluster, depending on however you want it. That, I mean, there are different kinds of designs, systems designs that you can use. Some people use names teams, some people use namespaces based on applications, different things, different reasons why you might want to do that, of course. And then you can also, what that means is that I like this, is a namespaces are able to divide cluster resources between multiple users. So you can have users that the only, so for instance, maybe the e-commerce team, all right, on the developers there, or the guys working there, will only have access to those resources. So nothing will concern them with maybe the billings team, or maybe the whatever team that you, however you want to section it. But it just gives you that flexibility to be able to do that. Okay. Any other questions? Any questions, especially regarding namespaces, so that we can, wow, time is fast spent. Okay, any other questions? All right, so if there are no questions, I have questions.
Hello,
Yeah,
sir.
go ahead. Yeah, go ahead, please.
Please, can you take the namespace again? I didn't quite understand it.
Okay. So namespaces. So for instance, now based on what we've looked at so far, right? If you have access to, so let me use the example. We have our application running. We have we have the deployments. We have our services running, on this cluster. And then now imagine if we want to have maybe another, let's say our company has an e-commerce application. Maybe it also has maybe HR application that is running, that's an internal application, for instance. Maybe it also has maybe another product, okay, that we are all running on this cluster, okay. And we have different teams. I'm just giving this as an example. Let's say we now have different teams running these different applications. We can break it. We can break our cluster and divide it in such a way that one team would only have access sorry, excuse me, will only have access to one particular namespace. Do you understand? So what that now means is that you know, you've grouped resources together. That okay, that's what, and you can say okay, this application cannot use this set of resources, cannot use more than this quota, you know, and all of that. And then also other reason is, you know, like to control access. Okay, so the developers who are working on the, or the, you know, guys who are working on the e-commerce aspect should not be able to access the HR application, for instance, or HR resources. All right, for us to get. So it's just a way, it's just a mechanism to be able to isolate, you know, resources, you know, in a cluster. Do you understand? It's just another way to isolate resources in a cluster. Let me give an let me try, let me give an example. I don't know how many. What's going on? Cube 6 here. I got so these are default. I don't know if you can you still see my screen? So these are defaults. What I just did was to get the namespaces. All right. So there's a default that comes with your Kubernetes cluster where you are, you know, usually, you know, is, you know, the default namespace. That's where, so if you deploy a an application there straight up, you know, it goes to the default. All right. But you can see there are other namespaces. These ones are system namespaces that come with, you know, this. I think this particular one, this is kind I'm using. So, you know, so it comes with, you know, like, you know, this different. So there's Cube Public, there's Cube System. Let's look at get pods. What was that? Cube System. So earlier on, we just did. I'm coming. Let me. Okay. All right. So you can see. Remember when we deployed when we created a pod earlier on. All right. We did it in our default namespace. All right. And when I did get pods, you know, you can see that there's only one. But then this is a namespace that comes with the installation. Okay. And you can see there are different pods running. You know, there are different pods. These are system pods. So core DNS, which has to do with you know, like DNS within the DNS discovery within the cluster. You have etcd. We talked about etcd earlier. Control plane. We have the Cube API server. We have the controller manager. All those things that we talked about, you can see them running as pods in this particular system namespace, where, like, you know, Kubernetes systems, you know, are running in. Okay, you can also create, you know, a new you know, namespace. Let's call it KCNA, you know, and then but of course, if you do like to get pods, you can see that there's nothing there because we haven't created any pod inside of the KCNA namespace. All right, but you can see we have pods running in different namespaces. So what we've done is that in this one cluster like this, we have several namespaces that are running different workloads that have different resources. Okay, and we've broken down, we've sectioned it, you know, like that. Different nations have different ways that they decide to structure their clusters. All right, but the one I was giving earlier on was just an example, all right, of structuring it like with your teams. Okay, here somebody gave another example, using environments, for instance. So you can have a namespace for dev, for prod. All right, but this is even a question. It says, what's namespace? We can create multiple namespace based on environment. For example, yes, we communicate with each other between namespaces. Okay. By default, no, right? By default, because services are namespaced. Okay. So by default, no. That's the whole idea of isolation. Okay, that's the whole idea of isolating the resources. But of course, you can always configure it to behave that way. Maybe you want a specific application to interact another. Joy, go ahead. Wow, we just have 5 minutes to 9, and I really want us to. So yeah, go ahead, Joy,
So with the way
please.
you explain namespace, I does it have anything to do with like when you're working on an Nginx server, you're doing multiple server blocks, right? So I want to understand, let's say for instance in an Nginx settings, if you're running multiple server blocks, it means you're running different applications in one node server. How does Kubernetes maintain that same structure for multiple server blocks? Like, I really want to understand how, if these are since let's say we have different applications, and let's say for a test environment or dev environment, and you don't want your applications or microservices to be in different servers, but you want them to run on one node server with the same resources. How do Kubernetes manage that aspect of multiple server blocks for different applications running on one server, on one node server?
Yeah, I mean that's essentially what we've been um, talking about. The fact that you can have different deployments, all right, running different applications here, all right, in one cluster. Okay, and you can now have the services that you set up. Later on, by next week, we'll look at ingress and maybe a bit more into networking. All right, you can now define, like, okay, especially if you're using ingress, because for instance you have given an example of a server block with Nginx, right? With server block, you're saying, okay, if a request has a certain header, maybe it has uh, is coming for a certain domain for a certain domain name, right?
Mm-hmm.
Um, points to this port, okay,
Yes,
which
yeah.
where one application is running. If it's coming with the header that has this other domain name, all right,
Yeah.
point to this other port, okay.
Yes.
Now, that is easily done in Kubernetes, right? With, for instance, something like ingress, okay,
Okay.
which we've not talked about today at all, right? It's easily done with ingress, all right? So you can tell ingress that, okay, if there is, anything that is requesting this domain name points to this service, all right? Anything that is pointing
Okay.
to this other domain name points to this backend service, okay? So that is, in that sense, I mean, it's easily achievable with Kubernetes.
Okay.
All right. Okay. Any other questions? Okay. All right. So first, I think I should also apologize for um, you know, it seeming a bit chaotic because um because like I said, we've had to park somewhere to do this. But let's just quickly wrap up. Where we just have 2 minutes, so we'll just quickly do our normal quiz, and then we will take it from there. Now, please, I know everybody has gotten their voucher for the KCNA James Spearing course, but please, I want you to continue to put in effort. This is not the end. We're actually planning some more rewards and bigger things in the end. Um, so please just keep pushing and engaging. Yeah. All right, so please visit this link. I want to set up the quiz so that we can proceed. Copy. All right, so that's the pin. Let me share my screen. Awesome. For those who want to QR code, there's the QR code here. All right. Are we still going with the no music today, or
Need to sign in. It's not showing where we input the pin directly.
well, somebody has already signed in?
No. My own is just showing get a quiz. How does class quiz work? Oh, play.
Oh,
Sorry.
yeah, play. Sorry, play. Yeah. All right, people are joining. Please, I encourage you to put your because we're able to track everybody because of the full names that they put. But however, there's one person that we've not been able to track. That's Dennis, and I'll actually also announce it on the Slack. So please, Dennis, if you are here, you please just reach me directly on Slack, because I'm sure you've not gotten your voucher and you're actually supposed to get. So please put your full name in the place for full names. So only 16 people have joined. Should we call it? Is that it? Is that everybody that will be joining? All right, so are we good to go? Okay. I'm trying to be as fair as possible so that we're not accused of. Okay, so I think so we're at 24 now. There are 26 people. Okay, so I think we can proceed. All right. So see you on the other side. So what is the primary purpose of container orchestration? What is the primary purpose of container orchestration? All right, so let's look at the results. Awesome. All right. In Kubernetes, what is a pod? In Kubernetes, what is a pod? Okay. All right. Next question. What is the primary purpose of Kubernetes namespaces? Interesting. What is the primary purpose of Kubernetes namespaces? Okay, awesome. Which Kubernetes object is responsible for declarative updates, scaling, and rollbacks of pods? These questions are easy. Oh, what's happened? Why did we set it so easy like this? Okay. This person is really vexing. All right. What does kube proxy do in a Kubernetes cluster? Hmm. Did we talk through this one today at all? We actually talked about it earlier. Well, even though we didn't go deep into it, but I know we spoke about it, so nobody should complain. All right. Awesome. To manage network routing. All right. So kubectl apply -f file name is used for what purpose? Let's see the results. What happened here? Only one person got it from the top 5. All right, Tekinos, well done. What is the primary function of etcd in a Kubernetes cluster? What is the primary function of etcd in a Kubernetes cluster? Okay, storing configuration data and state. Camille, they've dethroned you. All right. What is the purpose of a replica set? What is the purpose of a replica set? Okay. To ensure a specified number of replicas of a pod are running. Let's see. All right. Awesome. One of the following is not typically classified as a core control plane component in Kubernetes. Notice the keyword there, not typically. All right, kube proxy. Interesting. Not too many people got this one. Which command is used to create a new pod? So we want to create a new pod from the command line. How do we do that? Imperatively, how do we do that? kubectl run. Okay, so I think that's it. Show results. Awesome, Raman. You did it. You dethroned Camille. All right, so yeah. Awesome. Awesome. Congratulations to you guys. Raman, well done. Camille, well done. Faj Mayor, Tekinos, EHBC.
Sorry, is it the total point since we started or just
No,
for
no, no,
today?
this is for today. Oh, this is for today.
7,000 plus.
Yeah, for today.
Okay.
Yeah. If you notice the other one, somebody got 6,000 last week. If you remember, I think that was
Oh,
Camille's.
okay.
Yeah.
How do they get this 6,000?
So
Because
it has to do with like speed, the time you used to finish, like it's counting down now, right? So how
okay,
much time
okay,
did you use to do that? So fastest finger kind of thing.
Okay,
Okay,
not as
because
much. Because
I
I
also
did feel
noticed I got
much,
one, I got
but
minus.
the difference is much.
Yeah. Sorry, I can't see who is talking. Who is talking first?
So there was one of the question I got minus something, and I was surprised why I did, and that was like I chose the correct answer. And you also mentioned it, but I just can't remember the number. So I got minus something. My point was actually deducted. So I'm thinking maybe it's because of the countdown or so. I'm not sure.
Yeah. Sorry about that.
No,
Sorry, I'm
it's fine.
saying I was logged out and can't participate in the quiz. Why? I don't understand why that would happen, Emmanuel. Are you on the call? So no one is replying here. Okay. Anyway, so thank you very much, everyone. I will encourage you to please go back to the course, um, the um, the what's it called, the James Spearing course, because like we said, from the beginning, that course is like a companion course to this bootcamp. So please go back and do the hands-on practice with all of the commands. Just follow through, watch the videos, and especially the ones from week 1 and week 2, right? The topics from week 1 and week 2. Please, I will encourage you to really go back to those ones, because we didn't really have time. We don't. I mean, 2 hours is really like, especially with the fact that we are really doing other things as well, taking questions and all. We didn't really go deep into some of these things. Okay, but when you are in the comfort of your home and with that course, you can really interact with it, go deep, ask. Then also, I can ask questions on the Slack as well. All right. So thank you very much, everyone. Sorry, we extended the time today, about 10 minutes. Sorry about that. But have a lovely week ahead. Can you hear me?
Yes, yes, we can hear you. Thank you.
Okay. All right. Take care, everyone.